Hello everyone. Now let's have a look at this question here. So this question says that a boy booked the taxi and he is waiting for it on his terrace. After some time he looks that the taxi is coming towards him with a constant speed, and at an instant the angle of depression to the taxi is 30 degrees. Then after 6 seconds, the angle of depression has increased to 60 degrees. Then we have to find here that how much time the taxi will take to reach his home. Now we can see here that at the first instant, when the boy has measured the angle of depression, it came out to be 30 degrees. So we can say that in this triangle ABC, angle A will be equals to 30 degrees. Then after 6 seconds, when the taxi has moved a certain distance, the angle of depression, this angle has become to be 60 degrees. So we can say that in this triangle DBC, angle D is 60 degrees. So we have to find out that how much time the taxi will take to reach point B from point D. So if you look at these two triangles, these are again right angle triangles, and their common opposite is same, which is BC here. Now let's assume that the speed of the car is V, and we can express the distance AB and distance DB in terms of BC by applying the trigonometric ratios in triangle ABC and in triangle DBC. Then we can equate the value of BC and get a relation between AB and DB. So let's do it. So firstly, we are taking triangle ABC and applying trigonometric ratios. So in triangle ABC, we are finding a relation between adjacent and opposite. So we can apply TOA here since tan is opposite upon adjacent. So just apply tan 30 degrees here and get the value of BC. So tan 30 degrees is equals to adjacent. Opposite is BC and upon adjacent is AB. So we are finding the value of BC. So BC will come out to be AB, and the value of tan 30 we can put from the table, it is 1 by root 3. So this will be AB upon root 3. Now just focus on triangle DBC, and in this triangle also we can apply TOA, which is tan is opposite upon adjacent, and get the value of BC. So again in triangle DBC we are applying TOA. Tan of 60 degrees is equals to BC upon DB. Now BC will be equals to DB into tan 60 degrees, and we can put the value of tan 60 from the table, it is root 3. So BC will come out to be DB root 3. Now we can equate these two values. So BC is same, and we can get AB upon root 3 is equals to DB root 3. Just cross multiply these two terms and we can break AB into AD and DB. So AB we can break as AD plus DB is equals to, this we have cross multiplied, so this will become DB, root 3 into root 3 will be 3, so we can write down 3 dB. Now just take dB on this side, so AD will be equals to twice dB. Now we had assumed that the speed of the car is V, and this has traveled 6 seconds in moving from A to D. So this distance will be equals to speed into time. So AD we can write down as V into 6. And let's say that it takes t time to reach B point from D. So this distance dB will be equals to V into T. So we can write down AD as V into 6, distance equals to speed into time, and similarly this will be twice, speed is same, V into, and time we have to calculate. So this V will get cancelled, and if you solve this, the value of t will be 6 by 2, or we can say 3 seconds. So in this question also we had followed the same steps, which were, first of all we had made the line diagram in which we can see all the triangles which are involved. Then we had used the trigonometric ratios to find out a relation between the common side of the triangle. Then when we have equated the common side, which was BC, and find out a relation between the distances, and then finally we had used the relation distance equals to speed into time to get the final value of the time, which came out to be 3 seconds here. So we can say that the cab will take 3 seconds more to reach the person's home.